Many of us have heard about the majesty of black holes, the mystery of dark matter, or the bizarre world of quantum mechanics. Don't worry, we'll get to those in future videos. But before diving into the far reaches of the universe, let's start right here, with the fiery giant that makes all life on Earth possible. In this episode, we're getting to know the Sun better. The Sun is our huge source of light and energy. But wait a minute, is it really a huge star? Actually, no, not by cosmic standards. The Sun is what astronomers call a G-type main sequence star, or simply a yellow dwarf. It may seem gigantic to us. After all, more than 1 million Earths could fit inside it. But compared to truly massive stars out there, the Sun is just average. Some stars are hundreds to thousands of times bigger in volume. But don't let the word average fool you. The Sun is just right for life to exist here on Earth. So, where did the Sun come from? About 4.6 billion years ago, the Sun was just part of a huge cloud of gas and dust floating in space. Then something happened. Maybe a nearby star exploded, sending shockwaves through the cloud and causing parts of it to collapse under gravity. As the gas and dust pulled inward, it formed a spinning disk. At the center of that disk, the material got hotter and denser until finally it lit up, and the Sun was born. The leftover gas and dust around it would go on to become planets, including Earth. Now, here is the cool part, or actually the extremely hot part. The Sun is basically a giant nuclear reactor, but not the kind we have on Earth. On Earth, we use fission reactors which split heavy atoms like uranium to release energy. But the Sun works throughout fusion. It fuses light atoms, mainly hydrogen, into helium. This happens in the core where temperature reaches around 15 million degrees Celsius, and every second the Sun fuses about 600 million tons of hydrogen, releasing energy that lights and warms our world. But the energy doesn't reach us right away. When light is created in the Sun's core, it doesn't shoot out instantly. The Sun is so dense that light bounces around inside, kind of like being stuck in a crowd where you can only take one tiny step at a time. It takes 10,000 to 170,000 years for a single photon, a little packet of light, to escape the Sun's interior. Once it finally reaches the surface, which is called photosphere, it travels across space to Earth in just 8 minutes and 20 seconds. So, the sunlight you feel today, it began its journey before human ever existed. The Sun is about 4.6 billion years old, and it is expected to live another 5 billion years or so. But when the hydrogen runs out, the Sun will begin to die, and it won't go quietly. Its outer layer will expand, and it will become a red giant, possibly swallowing Mercury, Venus, or even Earth. Eventually, those layers will drift off into space, and the Sun will shrink down to a tiny, hot core called a white dwarf. It won't explode like bigger stars do, but it will glow faintly for billions of years before fading into darkness. So the next time you look up at the sky, remember, the light reaching your face started its journey thousands of years ago, deep inside a star. The Sun might be average in size, but to us, it's everything. If you enjoyed this journey into the heart of our star, give this video a like and subscribe so you won't miss what's next. In the next episode, we're not visiting Mercury. We're going somewhere far stranger, to a planet that should have existed but doesn't. A planet once believed to orbit even closer to the Sun than Mercury. A planet named Vulcan. Was it ever real? Why did scientists believe in it for decades? And what finally proved it wrong? Hit the bell and I'll see you in the next mystery.